In the previous video, I just had you finding the greatest common factor. And I mentioned something about factoring, and I want to take that a step further. Factoring there are a lot of different kinds of factoring that you can do. There's a lot of different levels of it. The very first kind that I want to teach you is greatest common factor, where we use that in factoring. So, and it's usually the type you should try first, so it's appropriate that we teach it to you first. Okay? When you do greatest common factoring, there's a few steps that you need to walk through. None of them are incredibly difficult, but it can be a little bit tedious, and as you work through it, you just need to be careful and make sure that you're doing every single part correctly. The step one is find the greatest common factor, and it is assumed of each term. We're doing it for each term in the polynomial. The second one is divide each term by the greatest common factor. The third one says write the greatest common factor on the outside of parentheses and write the answers to step 2 on the inside of the parentheses. And the last step just says multiply to check, okay? And you're going to use the distributive property. I want to grind through these a couple of times, and then I want to explain to you what's going on, why we are doing this factoring thing, okay? The first problem that I have up here to factor is negative 6x to the second plus 15x. Okay, find the greatest common factor of each term. Well, so we look at it. Remember, finding greatest common factor is what's the biggest thing you can divide out of both of them. Well, let's see, with 6 and 15, the biggest number we can divide out is a 3. That's the largest number. And x to the second and x, remember we use the variable with the lowest exponent, so we have a 2 and a 1, so we have 3x there. All right, I want to write that just slightly lower. And I've learned to write that greatest common factor a little lower because I'm going to actually use that when I get down to step 3. Step 2, divide each term by the greatest common factor. So I'm going to divide this one by 3x and this term by 3x. Okay, negative 6x to the second divided by 3x. Negative 6 divided by 3, that's negative 2. X to the second divided by x. Now don't forget we subtract exponents when we're dividing. 2 minus 1 is 1. So that first answer is negative 2x. The second one, 15x divided by 3x. Well, 15 divided by 3 is 5. Now since it's positive, I'm writing plus 5. X divided by x, well, anything divided by itself cancels out. It goes away. It turns into a 1, and 5 times 1 is 5. So we're right there. Now, for greatest common factor, take a quick look at what you had left. Is there anything else you can divide out of those? The answer is no. Since there's nothing else you can divide out, you know you got the right greatest common factor. And I just, boom, throw some parentheses up there. What's going on? Why'd you write the parentheses? Well, take a look at step 3. Write the greatest common factor on the outside of the parentheses, and write the answers to step 2 on the inside of the parentheses. These were my answers to step 2. This was my greatest common factor. It was my answer to step 1. Okay, so that's why I wrote them lower, and that way I could just put the parentheses around them. So I was looking ahead to step 3 there. All right, the last thing, multiply to check. Okay, so if I want to multiply this back out, this is just to check it. 3x times negative 2x is negative 6x to the second. 3x times 5, that's 15x. Okay? So that's factoring. I want to go through another one, and then I want to add something on to both of these. All right. The next problem, 5x cubed minus 15x squared plus 10x. So we have to find the greatest common factor for each of those terms first. 5, 15, and 10. I hope that's screaming to you that you can divide a 5 out of each of those. X to the third, x to the second, and x. There is a 1 on that x. Use the variable with the lowest exponent, so it's 5x. Then, step 2, we divide each term by the greatest common factor. I'm going to divide each of these by 5x. 5 divided by 5, well, that cancels. X to the third divided by x. 3 minus the 1 is 2. So I've got x to the second left over. Negative 15 divided by 5 is negative 3. And we've been doing this continuously now, so I hope it doesn't shock you that a negative divided by a positive is a negative, and I wrote the negative as a minus sign. X to the second divided by x. 2 minus 1 is 1, so that would be 3x. 10x divided by 5x. 10 divided by 5 is 2. Since that's positive, I write the plus. And since the x's are exactly the same, I cancel them out. Now look at x to the second, negative 3x and 2. Is there anything else I can divide out of all three of them? No, there's not. 5x was a good greatest common factor. Okay. So you write the greatest common factors on the outside of the parentheses. Write the answers to step 2 on the inside of the parentheses. So just place my parentheses and I'm good to go. Step 4, multiply and check. So I'm going to go ahead and just redistribute that. 5x times x to the second, well that's 5x to the third. 5x times negative 3x, that's negative 15x to the second. 1 plus 1, they each have, when you're multiplying, you add the exponents. 5x times 2 is 10x. So when I remultiply that out, I've got it. So here's my answer to the second one. I didn't circle it, but there's my answer to the first one. Okay, so I taught you how to do greatest common factor. And yeah, it's kind of a set of steps that you can work through. Here's the deal. Don't forget in math that everything we teach you how to do, we then teach you how to undo it. Okay? So we have worked a lot with the distributive property. So I want you to consider it this way. What if I just out of the blue gave you the problem 3x times negative 2x plus 5? Okay, and I said simplify that, multiply it out. So you would do the distributive property, and you would of course get negative 6x to the second plus 15x. Right there. That would be your answer. So doing the problem with distributive, we got an answer there, didn't we? Well, look at what we did. Negative 6x to the second plus 15x. I gave you the answer, and I had you work it backwards to get to the problem. You see, factoring is really just undoing a multiplication that we've already done. So I taught you how to do something, and then in math, we quite often teach you how to undo it. The opposite of adding is subtracting. Opposite of multiplying is dividing. Okay, the opposite of a square is a square root. The opposite of the distributive property in this case is greatest common factor. Anyway, there's going to be a second video with 3 more examples, and then after you watch that, go on ahead and do your homework. Good luck.